Problem number 4, notice we have a different kind of graph. This is a velocity graph, a plot of how fast it's going. So let's begin by describing the motion of the object very carefully. So what we notice is, at first, the object is not moving from 0 to 5 seconds, so make sure you specify that time period. We know it's not moving because the velocity is at 0. And then from 5 to 10 seconds, it goes forward at 20 meters per second. So when we get the total displacement, let's be clear, the displacement is going to be the total area. And to get that, I'll actually use a different color here. We'll just note that from 0 to 5 seconds, from 0 to 5 seconds, the area is 0, plus the area of this rectangle right here. Let's note that that shaded area here is going to be a base of 5, or rather a width of 5 and a length of 20. So 5 times 20 equals 100 meters. Now, in this particular case, the distance and the displacement will be the same. Basically, you take the absolute value of all the areas, and that'll give us 100 meters. Now, to plot the position as a function of time, let's be careful. Let's recall the velocity is the slope, so we're going to use this number here as a rise over a run. So for the first 5 seconds, we don't move at all. Next, we know that we have a slope of 20, so that means for every second, we have a run of 1 and a rise of 20. Run of 1, rise of 20, run of 1, rise of 20, run of 1, rise of 20, so that we wind up at 100. So that's the first one. And then for the second, for number 5, I'm going to actually work out both of these. So the motion of this object, a little bit different. Let's go ahead and describe it carefully. So what happens with this object is it goes forward for 5 seconds at 20 meters per second, and then backwards for 5 seconds at negative 10 meters per second. And we can use that right there. Okay. Now, what is the displacement of the object from 0 to 10 seconds? Let's go ahead, and we get that by getting the area of this graph. Let's be careful. So here's a rectangle. So we have this width of 5 and this length of 20. And for this part here, let's use a different color. Let's be clear that we have a length of negative 10 here and a width of 5, because we go from 5 to 6, 7, 8, 9, 10. That's 5 total. So the displacement is going to be the area, which is going to be 20 times 5 plus 5 times negative 10. And so when we add those two numbers up, we're going to end up getting a displacement of 50 meters. Now, the total distance is we take the absolute value of the area. So that's going to be 100 plus the 50 that we had before, and that's going to be 150 meters. Lastly, plotting the position as a function of time. Remember, this 20 is the slope, and this negative 10 is the slope. So for the first 5 seconds, our slope is 20. So we go over 1, up 20. That's the rise is 20. The run is 1. So over 1, up 20. Etc., etc., etc. And that's the first part. Now for the second part, our rise is, our value here is negative 10. That's the rise over the run. So we go over 1, down 10, 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 and that's how we actually wind up with 50 as our final answer. Notice also our displacement works out as 0 to 50, and our distance works out to be 150 as well. I'm going to have you do number 6, 7, and 8 on your own. I'm going to give you one hint for number 7. I'm going to give you the equation of motion. Just remember that this is V naught and this is X naught. So let's remember for the buggy, this is the equation for any buggy, but the answer you want to write down for number 7 is X is going to be 30 times T minus 120, like this. So those are your hints for the remainder of this, and I want you to use this to help you solve all the problems.